The U.S. Commerce Department spent a weekend patching a hole that it had cut in its own wall about a year ago. Here's the wall. For years, the U.S. has tried to keep the most advanced AI chips out of Chinese hands, the chips that train and run frontier models. The theory is really simple. You hold one critical choke point, and you can deny a rival the raw compute to build frontier AI. That's the whole premise of export controls. The hole was an enforcement gap. About a year ago, the enforcement of the rule governing global chip access stopped. So the overseas arms of Chinese companies, a subsidiary registered in, say, Malaysia, could just buy Frontier-class chips, no license needed. The new guidance, reported by CNBC over the weekend, follows the headquarters instead of the address. If you're headquartered in China, the license requirement now follows you abroad. So what slipped through in that year? By the estimate of one chip industry source with deep supply chain knowledge, hundreds of thousands of units. The most advanced processors on Earth, Nvidia's Rubin and Blackwell, AMD's MI350X, routed to Chinese subsidiaries in places like Malaysia. A former State Department official called it a huge problem and said that Chinese companies had very likely been buying these chips at scale. Now, hold on to the shape of the patch. It's enforcement guidance. It's not a full redesign. It does not require the data centers already running those chips to stop. It does not cut off the servers built around them. The compute is already in place, and it stays in place. So the wall was built to keep the compute out. But the compute is already inside and humming. That's the precise thing that the whole export regime was assembled to prevent. It happened anyway. Now let's look at this really carefully because there's more details and we need a sharper picture here. Look at what else is happening around this leak. Huawei's semiconductor chief, He Tingbo, recently named a path to 1.4 nanometer chip manufacturing by 2031, in just a few years, without any Western equipment. Alibaba is shipping a homegrown inference stack at commercial volume. DeepSeek's open model now runs on Chinese silicon, Huawei and Cambricon chips. So even as the chips leak out, the architectures get copied and the homegrown alternatives keep showing up. So here's the line I really want you to carry out of this one. The bet underneath every export control is that an advantage in compute can be held still long enough to even matter. A year-long leak of hundreds of thousands of chips is that bet not paying off. Now, there's a fuller treatment of where this whole control regime is heading in today's Century Report. Go check it out. All right, let's shift to another story here. Nvidia put a brain for robots on the internet this weekend, free to download, and it points at a very different idea of what machine intelligence even runs on. The model is called Cosmos 3. Nvidia released the weights on Hugging Face the same day that they announced it. Let me explain what it actually is, because it's not the kind of AI that you've been hearing about or using over the past few years. Most of the models in the news are language models. They predict text. Cosmos 3 is a world model. A world model builds an internal simulation of a physical space, how objects move, how they collide, what happens next, so it can predict the future and plan an action inside it. That's the thing that robots and self-driving cars have always needed, but we've never quite had. They have to move through the world, not just talk about it. And Nvidia calls Cosmos 3 the first fully open omni-model for physical AI. One system that natively understands and generates text, images, videos, sound, and actions. The trajectory that a robot arm needs to pick something up. One model does 3 jobs that used to take 3 separate ones. It can reason across what it sees. It can simulate an environment to train another system. Or it can be the backbone of a robot policy doing a specific task. Here's why a robotics lab cares about this. Training a robot usually means months of stitching together separate perception, simulation, control models, plus scarce real-world data. Cosmos 3 collapses that to days, and it ships in 2 sizes, an 8 billion parameter nano model that runs on a single workstation GPU, one good machine on a desk, and a 32 billion super model for the big research work. And Nvidia didn't keep it to itself. It stood up the Cosmos Coalition, robotics and world model labs, including Black Forest Labs, Runway, Generalist, Agile Robots, and Skilled AI, all building on open shared infrastructure. This extends a pattern from a recent edition of the Century Report. About a week ago, the Chan Zuckerberg BioHub released its Protein Biology Foundation stack as open weights, free to thousands of labs. Now the embodied frontier gets the same treatment. So the payoff is this. The intelligence that could build robots and self-driving systems didn't get locked behind a paywall. It got handed out to any lab on hardware that they already own. And it stakes a real claim. There's an ongoing debate in the AI world between people who really put everything into language models, which have done a lot to get us so far, and those who claim that language models can only go so far, and that the next frontier are these world models, people like Yann LeCun, for example. That bet is that machine intelligence for the physical world runs on world models and physics, a route running alongside the chase bigger language models path, not downstream of it. All right, let's shift away to another story here. An AI now checks the correctness of the chips that AI runs on. And the loop just got tighter. Cadence and Nvidia presented something that they're calling a Level 5 chip stack agent. To understand what Level 5 means here, borrow the self-driving ladder. Level 5 means fully autonomous. No human in the loop prompting each step. Earlier this year, Cadence showed a super agent that automated chip verification at roughly a 10-fold productivity gain. But a human still had to drive it, prompt by prompt, step by step, nudging it toward a design that met spec. The new agent closes that loop on its own. It evaluates its own intermediate results. It decides the next action, and it iterates until it converges. Let's ground what this is doing here. Chip verification is the slow, engineer-heavy part of chip design, checking that the design actually does what it's supposed to before anyone spends billions trying to fabricate it. It used to be bounded by how many human verification engineers that you had. This agent runs the whole chain itself, spec to RTL. And that's the layer where the chip's logic gets described through formal analysis, simulation, debug, and final sign-off. At Computex, Nvidia's CEO described the agent doing the work of thousands of engineers and millions of verification tests and finishing the loop in under a day. He framed it as a 40x improvement over the 10x figure announced only months earlier. Now, what makes it trustworthy enough to bet a product line on? That is a good question. But here it is. The agent's autonomy stays coupled to Cadence's sign-off accurate engines. Those are the proven models that give the final yes or no on whether the chip is correct. So the AI's decisions stay anchored to engines a company already trusts. And the jobs piece is one that people get nervous about, so let me be really clear about it. The boring part shrinks, not the workforce. Senior engineers stop babysitting tools that churn for hours and move to the architectural judgment that the agent doesn't yet supply. Younger engineers compress years of skill building by watching the agent work the whole chain end to end. NVIDIA's own framing is that silicon complexity has outpaced engineering headcount even at its scale. So this stopped being a convenience and became the way to keep the hardware roadmap moving. What's genuinely new sits under the surface. The rate at which compute can improve its own foundation just jumped. The chips that run AI now get checked by an AI, and the loop between what these systems can do and how fast their own hardware gets better just got shorter. All right, let's shift away to yet another story here. The head of U.S. Special Operations Command told troops to be very careful about letting AI into the delivery of lethality. And the weight of that is who said it. His name is Admiral Frank Bradley. He runs SOCOM, the command overseeing the military's most dangerous, most sensitive missions. At a Special Forces conference in Tampa, he said troops, quote, have to be very careful about how we come to AI's employment and its inspiration into the delivery of lethality, close the quote there. Then he sketched the future and named the bar it has to clear, a world where AI determines which targets to strike and the condition that, quote, we as humans have to have the confidence that it's going to deliver violence only where we intend it to be delivered, close the quote there. A combatant commander saying that on the record while the institution he serves is pushing to build AI into the force as fast as possible is a new kind of friction, because the caution is coming from inside the chain of command, from the person doing the deploying, not from some outside critic or an ethicist or a treaty advocate. And the institution's own AI use is genuinely two things at once. On one side, AI is handling the administrative load, compressing intelligence work, cutting what one acquisition official called the cognitive workload on mundane tasks. On the other, AI is finding and prioritizing targets. A Georgetown case study found the Army's 18th Airborne Corps directing artillery as efficiently as the best unit in recent American history, with 2,000 fewer service members. Helen Toner of Georgetown's CSET and one of the original board members who ousted Sam Altman from OpenAI made the point really plainly. The bureaucratic uses and the targeting uses are simply two true descriptions of the same expanding deployment. Now, a recent edition of the Century Report covered this same conference. SOCOM officials confirming operators use generative AI heavily and the command buying gear to run frontier tier models offline with no network. Now here's the upshot. The vocabulary for who's accountable when a machine decides where violence goes is being written from inside the institution that would have to operate it. That seems rare. Usually those rules get imposed after the fact from outside. The thing to watch over the coming months is whether Bradley's standard, confidence that violence lands only where intended, travels from a conference stage where he said it into procurement language and actual doctrine. That's the difference between a worry simply spoken out loud and a rule that the system has to pass. All right, let's shift away again to a new story here. A gene editing team found a way to sort the cells that they corrected perfectly from the cells they damaged in the process, and that widens the list of inherited diseases that a single precise fix can reach. So let's stay on the bottleneck for a minute. It's a decade old and it needs some explaining. CRISPR cuts DNA at a precise spot, but to actually correct a mutation, to fix the gene rather than just switch it off, the cell has to repair that cut using a supplied template. That repair path is called HDR, homology-directed repair. It's the precise route, and it's been the problem. It's slow. It barely works in the blood stem cells that matter the most, the ones that repopulate your entire blood system. And when a cell does take the cut, it often botches the repair, leaving behind damaging scars, large deletions, chromosomal rearrangements, genotoxic damage. So, the treated batch of cells comes out as a mixture, the good edits and the damaged ones, all riding along together. That's what kept precise correction stuck behind the cruder kind of editing, like the gene knockout approach that's already approved for sickle cell and beta thalassemia. But this new method, reported in Nature Biotechnology, is called SMART, S-M-A-R-T. It uses a temporary selector wired like a logic switch, an AND gate, basically. A cell only flags itself as keep me when both conditions are met, the intended edit is present, and it's correctly assembled. That let the team enrich the precisely repaired cells to 80 to 100% purity while throwing out the cells carrying the damage. And here's the really elegant part. The selector is temporary by design. When they transplanted the enriched human stem cells into mice, the grafts that took hold were fully edited, and the selector was gone, no longer detectable. It did its sorting job and then disappeared. Now let's be really careful with how this lands. This is demonstrated capability in human cells and a mouse model. It's not a therapy that a patient can receive yet. But what it changes is the date. By removing the purity and safety bottleneck that has held the precise correction back for a decade, it widens the map. Which inherited diseases could you possibly approach by actually fixing the mutation instead of just knocking a gene out? The doctor's office reality, where some genetic conditions had no precise option, is the thing that this starts to move. All right, let's bring everything to a close today. Look at this day as one motion. The chip export wall turned out to be leaking for a year. Hundreds of thousands of frontier chips are already inside and already running. A brain for robots got posted for anyone to download. An AI started checking the correctness of the silicon that AI runs on, and a method for sorting perfectly edited cells from damaged ones widened the reach. Those four run in the same direction. The chips move, the architectures get copied, the robotic brain ships free, the compute starts improving its own foundation, the cells get sorted to near purity. And underneath all of it sits one assumption coming apart. That an advantage in compute, in capability, in precision can be captured, walled off, and held still long enough to matter. The export regime is built on that bet. So is every plan to keep frontier capability rented and gated, and the evidence keeps pointing the other way. The capability diffuses outward faster than any single choke point can hold it, which leaves the one beat that runs the opposite way. the commander in Tampa, saying slow down on lethality. And he's saying it because the rule for how it's used is worth writing carefully by the people closest to the cost, and not because anyone thinks the capability itself can be contained. That's a standard being set out loud before the fact instead of after. The capability is going to keep arriving in more hands. The thing still being decided is what we ask of it when it does. We'll see you tomorrow.